Cool. All right. So I'm going to start with browsing Reddit. No big deal. I'm gonna start with setup, which you don't need to do because it's already set up, but like just to talk about it in case everything goes broken. Um, so or yeah, I don't know. Hello, I'm Jordan. I don't know. Wait, anyway, what's up? So if you want to use a CNC, it's a bit of messing around. It's kind of annoying. So like you start with something that you want to make into a physical object. You might have either a 3D shape, you could have like a face or something you might want to carve out of some wood, or you've got a line design or something else, but somehow or another you start with modeling. And then there are a few different programs you can use for this. Microver Fusion 360. There's a really popular one called Easel that is used with another version of these machines. And so you start with your model, and then the way the system works is like this is going to have to go from like one point XYZ, and then go to another point XYZ and keep moving around. And so you got to come up with the instructions for it to go in a path. So that's coming up with the drill path, and you need software that is able to do that. And then when you have that whole chain of places that you need the drill to go, then you export it. And so there's a post processor that converts the instructions to be compatible with your particular machine, because they can be slightly different. And then when you have the set of instructions, then you have to send them to the machine. And so it's a bit of finagling. It's not, like hit print, unfortunately, but I think they're like, I've never seen one, but like, I bet if you had like a really, really expensive one, it probably would be just print, but I don't know. Not 99% of them. So if anybody wanted to follow along, these are the pieces of software that you would need. And I'm just going to cover how they're like set up while they were already set up here. So I don't really need to kind of like do it. So the first thing is the way that these are set up. They're actually just like an Arduino. If you've there's a whole Arduino workshop, like there's just a microcontroller, a little computer in here running its own software. That software is called Gerbil, GRBL, and you need to install the drivers to talk to this board. So they come from this website, and it doesn't have an English website. So anyway, necessities, folks, I guess. And then you install that, and then when you plug the device in, it comes up as a COM port, which is like, if you've seen Arduino, same kind of deal. So a serial port pops up. Serial ports, you send information and the thing receives it. So when you have that set up, then you're going to use a piece of software called Candle. And Candle is it's a G-code sender. And I'll get into G-code now in a minute, but like this thing here is set to understand like a set of instructions. They are actually, I can just look them up, I guess.
Can I just ask a question about the unit you have here? Is that, just an off-the-shelf type one?
It's the most common hobbyist thing that you'll get. There are lots of different brands. This one here is a Sane Smart Genmitsu CNC. But like if you look up 3018, that's 30 centimeters by 18 centimeters. It's like the size of the board on it. They're all exactly the same, running the same board. And the other, there's like a 4040. It's 40 centimeters by 40 centimeters. They're all the exact same thing.
Yeah.
And they work with this open source Gerbil thing. So like you can swap them out. I've actually swapped out the unit on mine, and like I had one of these home, and I was just like walking by, and Rachel's like, "Look, we got one of those," and I was like, "I got one of those," So it's like
Okay, so it's sort of an entry level. It's not. So how much would that be? How much?
That was about $260 from Amazon.
Yeah, really, that's not much.
Ballpark.
I was expecting way more than this. I literally have no idea.
They're coming down. They were like 400 a couple of years ago.
So these $5. That's ours. Yeah.
Yep.
And Jordan, you have.
And so you're limited then by the size of the platform there.
Yeah, so there's a variety of these, like the manufacturing of it is what determines the capabilities of the machine. Like they're all the same, right? They all move X, Y, Z, and they got a drill on them, you know, whatever.
Yeah.
But these motors have a certain amount of torque in them. And when you're ramming a drill bit into steel or something, it's very difficult to do. You need bigger motors.
Right.
And if the motors aren't the problem, then it's going to be some other component of this. These black parts are made of a material called bakelite. And these are aluminum extrusions. So aluminum's pretty soft. And like, so as far as construction goes, it's not like sturdy. It's made for soft things. Like, so you can use it with aluminum, it's kind of pushing it, but it's mainly made for like carving into wood or plastics or foams, cardboard, those kind of things.
So if you're into like steel or something like that, then you might need to upgrade.
Yeah, but most of the people who would be building stuff out of steel are probably doing larger things anyway, and this is not a good machine anyway. They would be looking at there's units from I don't know, there's a whole host of companies out there. The Shapeoko is probably the most popular one, Pinoko. They are a bit larger, like they'll be like a couple feet by a couple feet. Bigger units, like those are like nearing, I don't know, they're like 1,000, 2,000 ballpark. But like beefier units, even in this size, can be like $5,000. And like Tormac or like the good ones, they're, you know, tens of thousands, and there's no limit, obviously.
Yeah.
So this one is good if you're making small stuff. You can use it to make prints or something. You can use it to make circuit boards. A lot of people buy them to do home PCB manufacturing. They're good for jewelry or make, I don't know, just making small things. If you want to make like a paintbrush holder and you got to drill a bunch of holes, it's hard to draw a grid, you know, if you've got a hand drill or something. So, you know, it's really good at that. But you know, every tool's got its limitations.
So this is one that is made here, on the wall there. Is that
That
one?
one.
Yeah, that's there's a piece of brass. And,
Yeah, okay.
it's very good.
Right, so anyway, brass, that you can obviously work with brass. Oh, yeah. You can do that.
Well, okay, it roughs up brass enough to make a line.
Yeah, okay.
But and if you flip it over, you'll see that it is actually kind of like, you can see the ridges on the back, because I mean, like it did make a pretty good mark in it. But if that was like an inch thick, this ain't doing. I cut that square myself, and I like, brass is hard. Like I probably would have been better off using copper or something else like you'd normally make you know, prints and stuff out of.
Okay.
Okay,
well, it's nice to see what.
Yeah, I mean that is a thing that you can do with it. I don't know. Yeah. So
Yeah.
yeah. That's what I want to get into here. So see if I can find. See, I'm using this computer, and I realize that all this stuff's like all the references I had are on my computer, and here we go. This might be it. This is not it. Sorry about this. I was going to do presentations and stuff, but I didn't want to be so like formal about it in case we got into some other things, you know. Complete list. That looks like a thing. Be a complete list. Yep, there we go. Okay, so this is covering G code. I'm going to prepare all this. This Google Doc I pulled up from this here website, and it's jpsmithnl.github.io/CNC workshop. This is just my GitHub account. I can write that down and send it to you. Can you see that?
Yep.
It's if you when you registered, like that link was on the registration page. But I'm gonna like dump all of these resources that I find there at the end of the workshop. Spam. Okay, so this is what G code looks like. It's called G code because they all start with G. I actually like it's like part of like, you know, in software there's this GNU new thing. So I think it's related to that. But there's a set of commands, and they like tell the machine how to do things. There's a G command that tells you to go to different coordinates and stuff. Like G and then some letters is a G code instruction. Then there's F for feed, S for spindle, T for tool, N is like a metadata or something like that. And so these are the G codes. G00, go real fast. You know, set up a line that you want it to go around and do different things. The details of these don't matter. You never actually see them. I'm just kind of explaining like what's going on. A lot of these are related to configuring the machine. It knows when it starts up, like how far it can go down and how fast it can move and things like that. And so you can set up these like zones and, you know, configure the machine. And for the most part, that's what the codes are doing. These are all going to be handled for you in software. So you don't need to manually do them. And it can come up when they're doing weird stuff that you need to configure them. Somebody will be like, oh, it's when this weird thing happens, you got to add G something to your code and it'll fix it. And
like shoulder grinding with face plunge.
what kind of workshop is this?
Like, I know, like, honestly, like, I had no idea what this was. David said it was like a free workshop. I was like, oh, come, I know you. And now I'm just like, looking at this being like, I can't wait to see what is gonna happen.
Yeah, I'll mention some of those things. Art learning.
With velocity factors, come on. Like, I'm
yeah, there's a whole lot of them.
Yeah.
Most of these the machines can't even do. Like some of these machines can go on angles and do all kinds of weird things. So this is like the whole set of instructions. All computers do this. Like there's something called assembly that every computer in the world runs on at the end of the day. Like programming code gets converted down into like there's like I don't know, several hundred instructions that a computer can do stuff with. They're like add or subtract or whatever, and everything boils down to them, and everything else is just layers built on top of telling a circuit to do the instruction. And so this thing has a set of instructions related to moving this thing around, and you got to figure out how to come up with a set of them to get it to be happy. It's a very fickle machine, so I don't know.
So in theory, you could learn G code.
People do
G code yourself, but
yeah, that is actually where these things came from in the first place. So in machining, like, so I don't know, is anybody like a machinist? It's like, okay, let's check. Somebody like tell me I'm dumb. But like, so most people know like a drill and like a hand drill or a drill press. It's like making a hole and it just goes vertically. If you had a drill bit and you pushed it sideways, it's not gonna like cut a channel like you'd expect it to. There are machines that do that. They're called mills. And so in machining, people started making these devices which had, this is a gantry that can move in multiple directions. So they made a vice grip version of that. They could put their work in, and then they stuck a drill on it, and then they could kind of hand torque it along, and the thing would cut a channel, and then they'd torque it the other way, cut another channel. Oh, look, I made a square manually by hand over a very long time, until somebody was like, you know, we can just put motors on it. And so they did that. And so the original G code stuff, like, and all of these things came from people manually running individual instructions. When they figured out how to make a part, they would have like a blueprint. They'd be like, all right, I got a square. It's like this far. So I got to tell it to move this far. And they would tell the motor to do it. Until we got to a point where like, yeah, let's just like draw my signature or some, you know, and then here we are. So anyway, so yeah, that's the it's a tangent on G code. But so you're going to use this software called handle to send your codes to the control board. And these are all like free open source software things. And so we saw earlier that it's connected to a particular port, and it talks at this particular rate. And so you set that up and it can talk. And if you connect it good, then it gives you this, and otherwise it says this. So yeah, anyway, and then you take it for a jog. So this moves it around, up and down, different directions. You can even control it with your keyboard. One thing that matters is the step. So a little tangent here, because this is sort of the end of that, and now it jumps into modeling. Like this is the instructions for like configuring this computer if this computer got crashed. So this device, like I mentioned, yeah, it's got a gantry. So a gantry is a thing that moves 2 directions, and so there's a threaded rod here, and this thing rides on it, and when the motor spins, the rod moves back and forth in this direction. There's another one over here, and then there's a small one that moves up and down. It mainly moves in like, you know, like along the table kind of directions, and it'll move like it's a 30-18. It goes 18 in one direction, it goes 30 in the other, and then up and down. It actually it's only this tiny gap right here, which maybe I don't even know the point in that. I assume it can see something. I don't know. I don't even know if it's recording. It might just be recording the screen. But so yeah, it only moves a little tiny bit up and down because it's really made for making flat things like this. But like if you're clever, you can make anything. So on it, it's got these motors, and they're not just like your regular motors. You turn them on and they go. They're called stepper motors, and so the instructions, and they run on instructions actually. You send them like a number of individual kind of like movements, like you say like degrees that you want it to turn. So you say, you know, turn 90 degrees. You give it 90 steps. It goes 90 degrees, and then it stops. They're really precise in their control, and it's got 3 of them for XYZ. And so really when you say like the G code is going to go to XYZ, whatever, you're moving like a certain number of steps. And so when this thing here is mentioning that it's going to move a certain number of steps, like this is the, it's going to control how fast this moves around. And so when you are setting this up in the first place, the steps, you might want to adjust them so that they're large or small, depending on, am I trying to move it from the corner out into the middle, or am I trying to like very precisely put it right back on the line where it was, you know? So you can control the steps down into like fractions. But yeah, let's jump into that. So it's good to like see it do something. The board is not plugged in because we moved everything. I'm just going to plug it in real quick for the sake of it.
How'd you learn how to do this?
YouTube.
So you're a, it's like, you know, this is something you do in your spare time. This is not
But
Yeah.
your 9 to 5.
What do you do? You're an engineer, right?
Yeah, I work in Shopify. Like they do online e-commerce stuff. So like you can set up a store website. Mr. Beast YouTube channel. I don't know who Supreme Clothing. Who's like doer pants I'm wearing. I don't know. Like they're like every shop that like has its own like standalone. You check, most of them are Shopify stores, and so like it's platform that runs those things. And I'm a data engineer.
But you did do engineering.
Yeah, I did like a master's in AI and stuff. But
Wow.
I don't like use it.
Sorry, I masters. Wow. All I knew is that you did something like really high tech or something. Like, I wrote this next. Wow, that's awesome. It's crazy. Wow.
Okay,
Sorry.
so let's see. So when you plug this thing in, I'm gonna just clear it out. There's a small switch on the back of it that you can probably not really see, but whether or not the light is on is a bit more visible. And when it turns on, there's a small fan on it, you can hear it. When the fan is on, the motors are able to move, and the light will be on, and then it can cause trouble. And then you turn the switch off, it can't move, even if you tell it to move. And that's really important because sometimes you're just messing around and you don't want this thing to go, and it can totally break itself. This thing is a little bit dumb. We were talking about this earlier today, because like I brought some switches to install on this. This is for the gallery app. Like all this stuff here, because I have the same stuff at home. For whatever reason, it doesn't come with like safety switches. I brought like a big emergency stop button.
Like it's a drill, right?
It's a drill with a mind of its own. I mean, like it's this big, so you're not gonna get hurt, but like it's still like a drill. Yeah.
If you had something that I couldn't drill in, or if there's something in the way.
It's not that it's gonna hurt you, it's gonna destroy itself.
that's right.
Mine's broken.
Wrong around it, which I don't.
Yeah.
People would do that, I would, I just.
Well, no, like, so this is clipped in, right?
Yeah.
And it's totally possible that you drill this in, it starts moving around, like this comes out unclamped,
Right,
and
yeah.
then it's spinning a piece of wood, and you're like, oh no, the thing is broken, you know, suddenly.
Yeah.
And so these switches are supposed to go on the side here. And when this thing moves all the way to the side and it hits the switch, it can't move anymore. It doesn't know where it is right now, and it can just move, and then it slams into the wall, and the motor keeps grinding, and it makes a horrible noise, and that exists. So
that's what the big stop button is for.
well, no, the big stop button is for when you fuck up, and and you're like, because it's dumb. You just tell it to do something, it does it. You're like, go down 1 inch, and it's like, okay, you know. And if you do that, and there's like, you know, concrete here, because you know, whatever. It's gonna just jam a drill into the thing and break, and like I've broken a lot of bits. That's how it works.
It's just doing what it's told.
Yeah,
Yeah.
computers are dumb. That's how they work. And so like, yeah. You can, you know, like we can set this up with some like safety features. It's probably a good idea. You know. Anyway, so I plugged it in and replugged it so I could actually see when I ripped it out. This is the error that you get when it's not communicating. And when it works, it gives you this weird cryptic Control X Gerbil 1.1F help me.
Money for help.
That's good.
Yeah, and then if you ask for help, it gives you that. Yeah, you're not supposed to speak machine code. It's like, okay, I guess. Yeah. Like I can run codes here, and like if I knew what I was doing and tell it to move around. But now that I got it plugged in, and if I listen really carefully, I can hear the fan. Now it can move around. Woo! Neat. And what I really like is the fact that you can see this thing moving around as I move it around.
Oh, that's the.
So when I drag the instructions over, you'll see them show up here, and this is 1-to-1. So like it's a precision machine. When it started off, it was at the origin here, this green and red thing, and then if I move it over 1 inch through instructions, this thing is going to be 1 inch to the side, and then this like virtual version of it will know exactly what's going on. And when you plug it into Fusion, I haven't fully set it up yet. That's what I was doing today when I wandered away because I had work. You can take this whole machine and there'll be like a virtual version of it, and you can simulate it doing stuff before you run it. And that is useful because it's dumb, and sometimes it will like try to come up with like movements that are impossible, because you know, it's just like, I don't know, you told me to go over there, I don't care if there's like something in the way, and you know, you'll see that. Anyway, so yeah, this is the machine, it's alive. A step size of 5 moves it this much. You can see, probably can't see, but like clicking it once moves it a little tiny bit, right? And if I set this step size bigger, it moves more. But when you're setting it up, you might set it down to a really small amount where you can't even hear it. It's moving a very, very small amount. And it's using a lot of code to do it. Like if you look at it, this is the instruction to move, and then you can see it's actually got X, Y, Z, and then when it works, it says, okay, I did that.
Okay.
So like you can actually just take take the line and I believe, I haven't actually been doing this, but like,
That's really cute.
you can,
Okay. Okay.
whoa, my code made it do a thing. Anyway,
So that we.
yeah, the platform moves when it gets these instructions, right? So now I just need to figure out how to get a that in order to make a that. You know?
So your bit moves.
Yep.
This way, and then your platform.
Yeah. So the platform moves like
Oh.
I don't know, drag it around or something, but like it moves all the way. Well, I can actually just move it.
Yeah.
Goes like this and the drill goes like that.
Yeah.
Yes, I get you.
So I set this up to move like. Okay.
Yeah.
So it goes all the way to there, and then it will go.
Yeah.
Gotcha. And then the drill.
And then you stop it because it will just destroy itself. And then in the other direction, it's sliding along that thing.
Oh, gotcha.
And then up and down, it's got this little tiny, all the like gray plastic.
Alright.
So yeah, like, you know, the actual working area of it is not huge. And there are different ways to do these. There is a CNC that you can buy that is used for making large scale artwork. So if you wanted to paint this entire wall, you would mount like a pulley on each corner of the wall. And then the machine, these motors, rather than moving along a rail like that, will connect to ropes. And then, yeah, and then like like all of this stuff here, the three motors and the control board will sit on like a pulley system and then move itself around the wall by pulling on the two ropes so that it can move to different locations. And yeah, so you can make like gigantic things if you wanted to do the mural up front or something. So this is sending code. Also it's a drill. So this here is the speed of the drill. And so it's set to 0, but you know, you can set it to 100 and it'll spin at 100 RPM. And whoa, it's moving. And it moves at up to 10,000 RPM. If you are changing the drill bit on this, unplug everything. Like, and I don't mean just turn it off, because if I turn this off, now, like I said, you're listening for a fan, and there is a slightly different light on the back, but like it's barely, I don't know, you can't probably even see.
Like
I'm turning it on and off here. And like with any machine, don't trust it, right? Like unplug it, because while it is not very big and whatever, and it is probably hard to hurt yourself, if you're holding on to it, yeah, it's still pretty powerful. Like, I mean, it's still a machine. Yeah, this is sending code, and this is manually controlling it. This one you've also Gallery's also got like the little remote control, so you can like take the little like Nintendo controller, and then you can like steer it around with this guy if you want to.
So
it's fun just to
stand and look down at it. Like,
yeah, it's like a little video game. And you can actually manually do it too. Like I said, people just started manually. People would just like have the thing telling it to go a little bit, and then you could, if you wanted to get freeform about it, like I've never seen anybody do it, but you could like start clicking around and try to draw a picture while the drill is spinning.
like an etch-a-sketch.
Yeah, but it'd be like an etch-a-sketch. It'd be horrible.
Exactly. Unless like really good at etch-a-sketch.
Yeah,
Like,
but like, you know, if a robot was drawn in etch-a-sketch, you could do it perfectly, right?
Yeah.
So anyway, some other things, user commands. Like I mentioned, this thing was lined up and then it wasn't, and now it's gone. So this resets the 0 in the X and the Y direction. If I click it, the little thing comes back. And then this one here is the X, Y, it's the Z, the up and down. And if I click this, you can't really see, I mean, there's nothing to look at, right? This represents the drill bit moving around, and if I like tell it to go to the side, you know, that is the drill bit. When I put something in here, it'll make a little bit more sense, but you will want to 0 it when you've set it up in the place that you want this thing to be. So right now I'm holding a piece of wood, and so you're going to want to put it in the center of the piece of wood when you've got it programmed in to be drawing on a piece of wood, and you tell it, well, the center of my drawing is here, and then you got the thing on the center, and then hopefully it'll do the same thing in the computer as on here, and it'll all work, and it'll be great. Realistically, probably not. I don't know. Something else that is a bit funny, that you're probably not going to come across unless you are doing that particular thing over there with brass, or some kind. It's got to be conductive, some kind of metal thing. When you are drilling into a piece of wood, I mean, it's a damp place here. You imagine, like, if I flex this a little bit, this is not flat. If you go to Kent these days, there is not a flat piece of wood in the entire building. I don't know what happened. Quality of wood is not good. But like, yeah, you can see pieces here, poplar. Wood bends, right? Everything is bent, and when this thing is drilling little tiny, fine, precise things, and you program in a big flat chunk, and you tell it to drill down a little bit down the whole length of the chunk. Well, if this is bowed out like this, on the edge, it's going to drill deeply, and in the middle, it's not. And that's something you got to be aware of. And so a height map is a system where you can program in the exact heights of everything, and then it will know that when it does its thing, and it will adjust for the actual shape of the material you're drawing on. So then you have to set up a height map, and that's a whole other thing. You don't do that manually. So if I wanted to set up a height map on this, I realized I've actually updated Candle, so this looks different than mine. And for some reason, use height map is grayed out, and I don't know why. But anyway, where did I put that? It's on my other computer, damn it. I have all these like visuals and like PowerPoint things like prepared, and I'm just kind of winging it because like I don't know.
Can you put them all on a drive?
Yeah, no, I'm at the end of the thing. I'm gonna post them all. But so
So then how, so if it was enabled and you
Yeah.
clicked on use height map.
Oh, you know what it is? I don't have any code in here. I think that's probably required for it to work, and I don't assume that there's any code here yet. That would be why it's disabled. But when it is enabled and you say create, what this will do is give you a grid, and it'll ask you like, how many points do you want to have? And when you take that piece of metal, and so this is how I would set up metal. There's different ways to clamp stuff down. So this here is a piece of wood with the clamps that are provided with it when you get this thing. This is called spoil board. It's just a piece of wood, and its intent is to be destroyed by this thing. When you want to drill something that is cut all the way through, imagine I want to make a gingerbread man. I'm going to want to cut all the way down and not just have a thin layer I got to get rid of later. So what you do is you tape it down to a piece of wood, you cut all the way through your material, and then like it'll still be stuck down, and you'll be able to cut all the way down. It will leave a score in this, but then you get a new one because it's just a piece of plywood. And so you tape that down, it's very flat. And then these here, you can adjust the height of them, you slot them into this here, and then you clamp them down off the wing nuts. So this can be clamped on just as well as that. This is a piece of metal, and what you would do is you clamp an alligator clip onto this, and then there is a marker on the back called Z probe. And I have all these things. I'm going to leave them all here because everybody's wanting to do this. But you set up the probe, and you put a clip on this, and you put a clip on that. It's all metal. The drill bit is metal. This thing is metal. This is metal. And so when you turn on the create height map, it knows how big of an area it's got to move around once you've given it instructions. And now I realize, because I didn't put anything in here, that's why it's disabled, because it doesn't make any sense. It doesn't know what to probe because I haven't told it where it's going to end up making a thing. And automatically will go and do like the 4 corners or the 4 corners in the middle or however many points you want it to do. And the little probe will like slowly go down and touch this, and then it knows that it's made contact, and then it's like, okay, that's how high that part is. And then it goes and it does it next door until it's got like a perfect grid. And then it comes up with this cool like rainbow 3D model of like where this thing actually is. Yeah, all automatically, and it looks cool. Caveat is that the wood is not conductive. So this works on my, okay, like I have to do it on sheet metal. This metal is 0.4 millimeters thick, right? It's very, very thin. And so if I want to cut halfway down in order to make a plate or something, I don't want to go all the way through it. And it's also metal, it's bent, you know? So I do this setup because I want that to be flat along the whole surface of the thing and have like basically all those lines be the same depth into it. And I have that. If you're using wood and you still have this problem because you're going to, there are a couple ways to do it. First, you can do it manually where you just touch the 4 corners of it. And so you set this thing down to not 10, but like a very small amount. And you manually just kind of, has it touched it yet? Okay. And then you say, record that one. And then you move it to the next corner. It's a bit labor intensive.
So there's no sensor thing to click onto that, but anything that's not.
There, and so that's the thing. There is actually a sensor that can go in here as it's like a drill bit. It's very big. So it's like I don't know, 3/4 of an inch maybe. And when it drags down from the thing here, this is all the way up right now. So this is this big. You have about an inch of working area when you're doing this. So yeah, it's just a limitation of it. The other thing I've seen people do is like put foil or something else on the material on the points it's going to touch, and then you can go and do the same process.
I was just thinking about that.
Yeah, so just like tin foil it.
It looks like a natural piece of wood, and in my head I was like, I wish there was a way you could cover that in metal somehow, and then you could tinfoil it, like,
It's covered in metal. Yeah.
You can find like.
Yeah, it's the problem is if the metal is bent, when you adhese, it's an adhesive thin sheet. You put it on the thing there, but it can be bumped up because it, tinfoil creases. And then if it touches the crease, it's not actually going to figure out the real true height of it. Also, it has a thickness, and so you're going to have to offset by the thickness of tinfoil when you do the programming for it. Just hold it.
So this is all if you just want to have a sort of shallow.
If you're being precise.
Yeah, so if you have wood, you're going a ½ inch into the wood.
Who cares?
Yeah, if it's not too uneven.
Yeah. So what people will do with this is essentially like make sure the wood is flat. Like don't use wood that's all bent up like this. Like, I mean, this isn't too bad when you're only cutting it an inch along. And like, whatever. Like if I hold that down, it's flattish, right? But like this is store-bought, it's flat. If you did find a natural piece of driftwood or something and you tried to do it, you're gonna have to go through that process, or you're gonna have to cut it down and make it flat. So you can run it through like a machine, like a planer, or somehow make it flat. I mean, even if you just like the way you might do with printmaking, lay a piece of sandpaper down and scrub it along until it is flat, you'll get flat-ish. And then you clean it up. Like a lot of people who are doing these kind of things, when you're done, you can get this machine to modify the material for you. There is something called a facing cut. So you take your drill bit and you say, fuck it, I don't care what's bumped up and what's not. Take the drill and move over literally every area in a square. It's flat now, and then you cut into it. The only problem with that is you've got a drill bit, which is like, it's not very big, and you've got to wait for it to cut down 30 centimeters by 18 centimeters of wood. Yeah, like you can do it. You're just gonna have to like leave it and come back tomorrow.
And like that'd be good if you're working for like tiny little components that you barely could get.
Oh yeah. See, if you're doing stuff with like jewelry, then you do that. This is not a big CNC. It is used for stuff like jewelry. It is used for printing. It's used for circuits, whatever, small stuff. if you wanted to make a big thing, you probably want a bigger machine. You know, and those are the trade-offs. Also, this is a precise machine because it is small. The bigger the thing is, it's sort of like, you know, if just imagine I've got the drill on the end of this thing and I'm trying to very precisely do something, you know, versus I'm up here on this end of it trying to precisely do something. The bigger it is, the less precise the machine can be. It's not made for detail when the thing is like 10 by 10, right? You know, 10 feet wide. So this is made for small pieces, and you got to get the tools for the thing that you want to do. This is really good for printing. You know, so yeah, back to modeling and other stuff. So yeah, say you want to do this. I'm gonna actually start over because yeah, I'll show you what I'm doing. So this is Fusion. It is a professional engineering program that can do lots of stuff that you don't ever want to do, really. It's a fully featured thing. It's free, and it's great, but yeah. So if you've never seen these things before, you ask what the hell shoulder and face and chamfers and fillets and what is all this? So if I've got a piece of material, flat part, that's a face. Shoulder is it's an edge on another thing. If I have a drill bit or something, you know, shaped like this, like the shoulder is like the little like offset piece here from another area. Chamfers and fillets are like if I flatten out the edge here versus it's either round or flat, chamfer fillet. So you know, the way that this works is a little bit different than 3D modeling programs, especially if you are doing sculpting. It's a totally different workflow. It is like, tell me how many millimeters the thing is, and you have to define all of the different areas. So the way that it works starts with a solid, a sketch. You'll notice as I'm clicking around here, this is like a flat plane that is moving in different directions. And then I've got a little box here that tells me about the top side, whatever, but like, it's kind of hard to see, but this says Z is blue, X is red, and Y is green. So when I'm picking this face and I click here, this here says Y and X. So this here is X, this here is Y, and this machine has an XYZ as well. I want to get stickers. I meant to print the stickers out and bring them, and I forgot to do it. But on the back of the machine, it says X motor, Y motor, and Z motor. The Z motor is always the vertical one, but it can be a bit confusing about X and Y. And when you go to line your machine up with the thing you're trying to do, say you're trying to do something long, it matters that it, you know, which way it's oriented. And so you look at the motor that says like X and then follow it out, and you know that X is one direction, Y is the other direction. It's good to like have it on the device so that when you put your material in there that you've got it all lined up well. But it is very easy for you when you start to click on a thing and have this go Z and Y, and then your whole design is like sideways, and that's a bit messy. So yeah, the first thing you do is start a sketch. So I clicked on the sketch icon and I select the flat thing that I'm going to do a sketch on. There are all these like, you know, drawing kind of things that you can do, like make a rectangle. So I click on the center and I drag it out, and I've got a rectangle. And it's at a weird sort of dimension. It's 66 by 77 and whatever. So the way these programs work, when you select something and say, I'm going to tell you how big this is, it becomes a dimension. And so this thing is about 60 by 60. This is a caliper. Generally, when you're doing this kind of stuff, you want to be measuring everything as you go, because like it matters. If you try to eyeball it, you're totally going to end up driving a drill into like the clamp. So I can see this is about 60 by 60. So I'm going to run 60. And then I get the sketch dimension, 60. Okay, I made a square. I got a square thing. We're in business. There's another side here, and if I try to do this, you see that it already comes up as 60. This is called a driven dimension because you can't have this be a square and both ends not be the same, right? That makes sense here when it's just a square, but once you get a really complicated part, you can kind of lose track of like where you've told the dimensions to be, and it's just something to bear in mind. So it's sort of intelligent in that, like, well, the first one is defined, and so the second one can't be. And it does those calculations for you, but like when I set the first one, it actually changed the dimension of the rectangle. Like if I click on that and I just make it like 5, it doesn't, you know. But like you got to keep track of, is it driven or driving, right? And it's just something you kind of have to sort of feel out. So I sketched a square. Cool. All right. There's all this really complicated stuff you can do with surfaces and mesh and sheet metals and plastics and utilities, and you can use this to make circuit boards and there's like an AI driven thing where you can like figure out the like forces on a thing and make like a organic mesh to support your stuff. It does all kinds of ridiculous stuff. I'm not going to do any of that just yet. We're gonna make a square. Okay, so I've sketched a square and then I go to solid, and pretty much all of this kind of modeling is extrusions. And extrusion is not just extruding, which is to pull and make something. It is also to cut down into something. So the nice thing I like about Fusion is that when you hover over actually anything in the program, it tells you what it is. So if I hover over what is this icon? What does it mean? It's like, oh, that's create sketch, and this is what a sketch is. And you know, you can kind of like, if you don't know what something is, you just hover. So I click on extrude, and so this is flat, and it by default is trying to say, okay, I got something flat, and I'm gonna like bring it up and make a cube, and you know, whatever. The funny thing I'm gonna do now is drive it down because I'm carving into it, and so I want flat to end up being the top of my material instead of the bottom of it, just because it makes references easier. So I can set a negative dimension, and then this will make a shape like this. I know that happens to be 19 millimeters. This is kind of funny. It sticks out the bottom. If you want to measure a depth, you do it like that, and you know, measure that. There are two sides here. There's inside, and then there's outside. So it also does inches and millimeters. You can just convert it. And anyway, so
where do you get one of those colors?
I am. You said there's already one kicking around. Yeah, you can get them anywhere. I'm going to leave this one here because it's an essential thing for doing all the measurements. But yeah, you can get them anywhere. Good ones. Right here on the thumb thing, there will be a wheel, and you can kind of rub it with your thumb, and it will adjust it for you. And they'll have a screw on it that you can pin down. So you pin it at like 5 centimeters or something, and then you can like use it to mark things, and you know. So good ones are made of metal, and they have a thumb wheel and a screw. But it's good. So if I hit negative 19,
What's it called? Caliper?
caliper,
Caliper?
calico. All right, I've made wood. Great. So I'm going to say that this is the wood. And when you're machining something, the material that you're starting with is the stock. And so this is going to be what they call a body. So all of these things that I've messed with like still exist. Like this top thing is my sketch. It's flat, and I can turn it on and off. This is a body, and all of these are grouped together to become components. This is the origin. This is the starting reference kind of thing on it. And so this is going to be my wood, and then I'm going to make a new component.
Can I get a value put in for the wood? Does it really matter?
Yeah, it matters that my origin is on the top flat part, and I'm going to set this thing up on the top and then drill down. But like you can also fix your origins later through a complicated process, and you can also like, you know, up is down if you look at it from the right direction, right?
Like what I mean is like, does this blue object you're starting with
Yeah.
have to mimic the dimensions exactly of your wood? If you're not cutting all the way through it, like.
Yeah, no, so it, the machine does what it's told, and I'm gonna tell it to start drawing on the top of the wood.
Yeah.
And so when I say to go, it's gonna start at the origin, wherever that's placed. It's gonna actually start in the middle of this block. And it's gonna drill down, and I'm gonna tell it to drill down 1 millimeter. The fact that this is 19 millimeters thick is irrelevant, except for the fact that like when I'm modeling it, if I do want to cut all the way down through or whatever, like you always kind of mimic the thing as best as you can, because it helps this thing when it figures out how to do the drills, because it does that automatically. Sometimes it does really weird stuff. I've seen it like kind of like trying to draw out around the thing or draw in under it and like do impossible stuff. And it's because it gets confused by the way that you specify like the setup for it to automatically figure out the drill paths is like really particular, and it can take a couple of tries.
So like just do yourself a favor and like
do it as accurate as
Yeah.
possible for yourself. There's a simulation step that'll come up later that yeah. So yeah, this is as close as possible, and if it's off, like so like remember I was saying that it's going to try to figure out the size of the shape to like probe it. It's going to use this drawing here. So if this is really out to lunch, then it's not going to probe the whole area, or it's going to probe areas that don't exist or something. So all right, so this is going to become my material, and then I'm going to make a new component that I'm going to call SVG. It's a vector graphic that I'm gonna use an SVG to like draw a shape under this, make stamp. So I've got that's my stock, and then view it all again here. I'm gonna click on the top of it. This is gonna make a new sketch, and then I'm going to insert a new. So SVG it's a yeah, they're used in like
like a
vinyl cutters use SVGs, yeah.
Could you use a file from that and modify it?
Yeah, you could, like if you're used to using like Illustrator or whatever, it doesn't support those directly, but Illustrator can export to SVG.
Yeah.
DXF is a drill path, but you can also use DXF in some vinyl cutters. Like I don't know, McMaster Car is a it's like the Walmart of buying machine parts. And so like you get all kinds of screws and different things in here. But so I want to insert an SVG. Okay, so how do I get an SVG? For anybody who doesn't do that, who's not making their own code or whatever, you've got what about here. All right, I went to Eastern Edge website and I found this picture. It is their logo. And I'm like gonna carve that on that maybe. But this is hand drawn. Like it's actually kind of wiggly, you know. It's also pixely. So this is what they call a raster, and it's a grid where some of the dots in it are black and some are white. And so when I'm telling this thing to draw along, I don't want it to be bumping all the way around on this S here. I want it to do a smooth curve. Vectors scale indefinitely. You can keep zooming in, and like, you know, a curve is always a curve. And so this is not really a good program format for this kind of thing. So I want to convert it. So I'm going to use Inkscape. Inkscape is a free software for doing vector stuff. Illustrator is like the more professional, like paid one. So I open that up. And wait.
If anyone has ever gone to mine, you retain your email address. You take advantage of student pricing.
Yeah, that's key.
Yeah.
Yeah.
So that's how I
Really?
got Adobe. Yeah.
Yeah, no, they can get you Adobe stuff, and they can get you Microsoft stuff, and
Like library subscriptions.
Yeah.
magazines.
I still go to the library and stuff.
Yeah.
I just like.
library's forever dope.
Yeah.
Yeah.
Like, oh,
I don't know why computers like okay. So it is time to draw the program. Cool. So I have a drawing that I want to import. It's under documents, CNC, no, what? I don't know.
It was him.
Where is it?
I don't know why I'm telling you.
For Inkscape files.
No, well, I'm looking for the actual drawing I was just talking about. So I ripped this off the website for Eastern Edge, and so I opened that up, and it's asking me about dots per inch and all these things that I don't care about because I'm about to just convert it into an SVG. So it's still a raster, a bitmap. It is no good. I need to trace bitmap, and as soon as I import a bitmap into the vector program, it's like, you don't want this, let's convert it. And it's even a little bit careful of like, is it pixel art if you want it to be squares? But you can set up all of the different like things, and then you say, sure, whatever. And then it traces it out. You'll notice it's like not great. You can like tweak it a bit to make it a bit better. This looks a little bit chunky. But now that I've got a vector version of it, I don't need the original. I go to File, Document Properties.
So if you zoom in on that, it's not like chunky like it was in the door.
Yeah, I'll do that in a second. So like resize it to content so it's not like this each page. Zoom in.
Whoa, yeah.
Yeah.
Cool.
Now it's like it's a bunch of curves. So this is like a control point on the curve, and I can like technically go and like
Oh, neat.
Woo! And like a curve is a curve at any scale, so I can zoom in and like, you know, curves are curves forever, right?
Yeah, really, really precise.
It's like drawing.
Yeah. Now, it didn't do a good job with the trace, whatever.
But if these are
It's fun.
quality images.
Yeah, it was like a pixelated image, and then there's
It
like,
was hand drawn anyway. It was like.
yeah, and there's like all these different like things that I can configure to try to make it better. I don't care. So this is a drawing that I'm gonna want it to draw, like, and because I can set it up to be like, go to this location and then draw in a straight line until you get over here. Like that's how the instructions are set up. So this is a really good format for controlling this guy. So all right, I saved that. That's my thing. It's not actually saved, it's like export. I don't know. And you can export it as PNG or SVG or whatever. I did this earlier today, so it's already there. And then in this program, I'm going to insert a newly made SVG. Insert from my computer. There's this whole thing about projects, and like it has a cloud save and all this nonsense that I don't care about. Like you have to pay for it. I don't want to. Okay, so it's put it in here, but it put it at 0, put it at the origin. That's not a great place. And unfortunately, I don't really know a better way to do this because even though you can like use the arrows to slide it, these are grids of a certain fixed size. And so it's like the better thing to do is like just kind of manually be like, I don't know, 20 centimeters. And you play this game for a little bit. This game. Sure, that's like centeration in that direction. And I'll go, I don't know, 20. Oop, negative 20.
Where do you see how big you're inserted? Like the thing that you.
So remember that I drew this out to be 60 centimeters. So I know that this is this block here.
No, the SVG that you inserted.
Yeah.
Like, can you resize that once it's in this?
Yes. You just have to do it in this kind of clunky way where I can like scale it up and say like make it 5 times bigger.
Okay.
You know.
So does it insert it like in relation to what you're working with?
So it's in the sketch panel. So I select a face that I'm going to put it on, which is just like the flat part here. I create a new sketch and then I go to insert, and it's going to go into the sketch on that flat face.
Okay.
And it's going to start. It always inserts it at 0, 0. So in my drawing here,
I'm not worried about bringing a file that's gonna be like, you have to like try and bring it down to the right.
it can do that. Yeah, like this here document is a certain size. Like this is in millimeters, 44 by 37.
Okay.
And my thing that I'm trying to put it into is 60 by 60. So
you can export it as a specific size.
yeah, and so, but if I exported it as like 2 feet wide, I would see a gigantic like corner of a letter. Yeah, it ain't friendly. This is the like, you know, it ain't just printed out kind of whatever. It's like here we are.
It's different from 3D printing, yeah.
Yeah. And you just gotta finagle it so it's happy. You're just in time to watch me guess at what letter or what number makes this center. Yeah, all right, so now I've got a block with some stuff on it, and if I drag it around, I can see like there's actually like a 3D thing and it's sitting on the top. I'm going to collect all the materials and anything that I've looked at and put it on the website at the end so you can go back and look at any of these things. So we're just modeling this piece of wood, measured it out 60 by 60. We made a gray version of it, and now we're sticking a drawing on it, and we're going to figure out how to get this thing to start drilling that out and make like a stamp or something. So yeah, this is our little 3D widget. Really hard to see. It looks a lot better on the screen, but so these lines are all little vector lines that it's imported, but they're flat and they're nothing. Like they're not a physical object yet. There are 2 ways that you can carve out something if you want to make a plate. I'm not going to this. So like this was done with this process. These brats, make a stamp with it. So in order to do that, I had a drawing that was lines, and then I used engrave. And so the engraver will follow the lines. And so like in this one here, I'll get kind of hover there, the green part to see. So you can get it to trace out that line, but like the logo, this part here is black. And so if you're doing a print and you want that whole region to be flat, engraving is not the ticket. So you kind of got to decide here, like, you know, what way do you want it to draw this thing? Is it a set of lines, or is it a set of like areas or whatever? And you can mix and match too. This thing is able to do lots of different things. And software has like way too many configurations. So what I wanted to do is this area here that was black. I'm going to do like the logo, but inverted. So like the black region will be white, and these here will be, it's going to engrave the parts that of the logo that are black. And so this is still a drawing. I go to solid, I go to extrude, and I'm not extruding out a thing. I'm not putting a bump on my piece of wood. I'm going to cut in so you have to select the operation. There's all these little fiddly things. This piece of software is enormous. People spend a lot of time learning them. There are a lot of guides online though. So if you want to sit down and just like waste an afternoon, just, you know, figuring out, you know, fillets or something, or chamfers, like it's there. So I want to cut down this chunk here a little bit. I'm going to go down, I don't know, -1 millimeter.
And it automatically recognizes that.
I clicked the area between the lines here, and so it knows that this is the thing that I want to do something with, and then I told it to go down a certain distance, and then
So that's a little bit clever at helping you.
Yeah, it's clever and too clever, you know. So now I've got a block with like a gap in it, and what I'm going to want to happen is this match that eventually, right? I've lost my sketch. So by default, for whatever reason, like these things turn off and on. You kind of have to like go through some steps to like bring them back if you want to do more things with them after you've done one thing with them. I don't know why it's like that. Anyway, so I did the E, and now I want all of these letters to have the same process. So again, it's not a new body. If I do new body, for example, it will raise or cut down the thing. It won't leave a hole. You can use Fusion to do 3D printing too, right? And in that case, when you do an extrude, that is an extruder machine. It's really good for that. And so I could extrude out all the letters and have them be raised instead of cut down. This thing only cuts down. I don't know. There's different tools for different purposes, right? So I'm cutting down, and then the way that Fusion works is like, it's always got this like little selecty blue thing. And then when you're in that mode and you hit shift, you can select the different things that you want it to operate on. And it's half smart, but like too smart, right? So I can select, right now I've selected the entire flat of the square. Now I'm selecting the E, but I can actually select the line of the E and also the inside of the E. And the funny thing is that the line of the E, it knows that doesn't make any sense to cut down, so it will convert it to be the inside of the E and cut that down. Right. But it'll be weird. Like certain things, if you select the line versus selecting the area, especially with the drill path stuff, it does bizarre stuff. So if I tell it to like carve out this thing here, I could get it to carve out between the lines. I could get it to carve down to the line that's in the bottom, or I could get it to carve the flat of the bottom. And those are all different operations, and it'll try to figure out what you mean. And sometimes do weird stuff, like especially selecting the line will have it sometimes do stuff where it like drills like outside of the wood, and it'll just kind of float around drilling air. Because like it's like a line, it doesn't know anything else, and it's just like, okay, you told me to put the line there, so I got to figure out how to get that line to be there and sharp. And so like it kind of like drills nothing and drills around the line that's there rather than drilling down into the wood like it wanted to. Or there's a lot of weird configurations, and you know, if you're doing this simple stuff, all of these extra things are useless and problems, and they don't make a lot of sense. But if you were trying to do like a weird organic shape, some of these funny things that it do, they'll make more sense, you know? Like if I had a curved line around imagine I had like a candy cane with a curved line on it or something, and I wanted to cut down, I'm telling it to cut a curved line or something, like it would make sense for it to float around and do the weird things with a line. Whereas otherwise, you know, in the flat area, these are just like confusing. Anyway, so I gotta click all the letters. Click that one, click that one. This is annoying when you have a complicated kind of thing. This thing here, I actually had to click all the individual like lines on it in this process. I don't know. Some of the operations allow you to like drag and select, but I do this just to be careful because it can be bizarre sometimes.
Are you holding shift while you're clicking on it?
Yeah, I'm hitting shift. The controls here, if I scroll, it zooms in and out. If I click the scroll wheel and drag around, it will pan around. And if I hit shift and then click this thing and then drag it around, it will orbit. I don't know. There's a lot of little things. There's also icons. So there's orbit, pan, zoom. Icons you can click if you don't know the sort of hotkey versions of it. And there's a lot of tutorials. So, you know, it's worth doing that if you're getting into it. So I've clicked the flats and I want them all to go down into it. And like it knows, you see how it's coming up in red, the inside cuts. Like when I select the flat, like this is the thing, like it's kind of telling me with the red that like, well, this is inside that. What do you want to do, right? Because if it's not like closed, I don't know, sometimes weird things can happen. Anyway, so -1, like the other stuff. Cool. Now we've got a hole made. Cool. This is the extent of the design phase. Like this is now this is what I want it to make. Except for now I've got to get to the step of it figuring out how to do that. So usually you'll save it. With the personal version, this is a caveat. Also, I noticed that somebody downloaded Fusion already using the Eastern Edge email. This is that account.
Yeah.
I think your computer's down.
Thanks.
Plug it into the thing.
Yeah, good point.
No.
The personal use version of it gives you like 10 drawings that you can keep. And make them editable. And what you have to do is when those are 10 active ones, so you convert them to read only and then save them and put them on your computer, and then you get 10 slots back. It's like a weird way to handle it, but that's anyway. So I save this as a EE, I don't know, whatever. So that's my drawing, and then there's all these different things that you can do. So this is the design. Remember the really weird generative design thing I was mentioning? Like, what if I had a physical thing and I wanted less material, like I'm 3D printing it? When you do generative design, it figures out like, well, the critical components that hold load are here, and then it does these weird spider webs of design. I don't know. Yeah, you can't do it in the free version. You can do realistic renders of your stuff. I don't care. I'm not doing that. You can make animations, and you can have multiple parts that all like fuse together and make assemblies, and like you can do physical testing, and like there's all kinds of ridiculous features that are in here if you're machining things. And this is sort of the hobby version, and we're using like the pro software. It's what you don't need any of it, but like anyway, it's there. It's a good way to get into that kind of thing. Simulation will tell you like where the weak points in your parts are. What kind of like, hey, if I made this stamp here out of stainless steel, how many tons of pressure would I put on it before it started to flatten out? I don't care, but like I don't know. Yeah, anyway, so what we want to do is manufacture. So we want to come up with the toolpath strategies for the design to be fabricated. All right, that sounds good. So all of the edit stuff goes away. And now I got to tell it to drill out this piece here. But you see how it's kind of like it's selecting the whole flat. And now in here, it notices that there's a middle. The way that I separated that into two components, I have one body that is the wood, and then I've got a separate component that is my my drawing, right? And so I did that deliberately because I want to tell it that the wood is the stock, and I want you to remove the other part from it, and that'll help it figure out. If you put them all on the same component, it'll still sort of figure it out. It's just sometimes there's weird stuff. I don't know. You kind of got to work around the software and get used to it. It's like that. Okay, so the first thing to do when trying to manufacture something is to tell it about the machine that is going to do the manufacturing. That's a problem because I haven't set that up. I'm going to have to do it now. The machine, well, I don't have a machine. Cool, let's make a new machine. I can, like, if this was, I don't know why, this is like the most generic thing, but because it's not a brand name that Autodesk could make a contract with, it's not in here. But the generic 3-axis is functionally exactly the same. The only caveat is like the simulation won't be as good because it doesn't look exactly like this. And so you see like, is simulation ready? Yeah, well, anyway. I'm gonna just like do one from scratch. So a lathe is how you make like table legs in a spinning thing. Cutting is like if I have a plasma cutter or a laser cutter and I want to do flat lines. Additive is 3D printing. So I can actually take this thing and hook it up to the 3D printer and use Fusion to do 3D printing as well. But this is milling. Milling is when you cut down and then go sideways. I'm going to create a new thingy here. Again, YouTube 18. Now this is safe on the computer. You only do this once for the lifetime of the machine, and we could go in and probably plug in the 3D printer and do all those same things. The only thing it can do is milling. It doesn't support tool changing. It supports one drill. the feed rate, the fastest it can go is, I'm pretty sure, like 650. In the X, Y, and Z, this is telling me how far it can move in each direction. So I wish I knew which one was X, because one of them is 30 and one of them is 18, right? So what I can do, it's a bit hacky, because I can move it around here. You can set this step to 5. Okay, so this, oh wait, that comes up here. This is X. Ah, I was actually just gonna unplug it. Let's see what happens. Okay, so this is X going that way, and like, I don't know, I had stickers made, I don't remember. But that's important to know. Is that a pencil or something? You had a pen, I don't know. Z is up and down, I don't know why.
So why is the wood piece that moves and X is the drill, the bar on top that moves?
Yeah.
So why is there?
Yeah, so X is this way, Y is that way, Z is that way. Okay, so back here, so the X dimension is this way, it's 30 by 18. I think. The Y would be 18 then. So where's that? I don't know why. I don't know why it's not telling me the oops. I don't know. It's supposed to tell me the size of the table, but like I don't see X and Y. Which is important because like that's how it figures out how to not like slam it to the side. So I don't know, whatever. 650. So putting this stuff in here presets some stuff. When you say I'm going to use this machine, it's not going to, it'll usually say like the default speeds for stuff that it's doing. I could also set the home rather than to be 0, 0, which is in the corner, to the dead center of it, which so in the X, if that is the X direction, that's 30, and that is 50 and 90, I guess. Okay, sure, whatever. And so that's the setup, and I'm going to say that my model is the drawing component here, and then the stock, by default, it's offsetting from this thing that I've got by a certain amount, like 1 millimeter, which is a kind of a weird thing for it to do. You can use this to kind of like say, I got a fixed size material, like it's a tube or it's a square or whatever, rather than like modeling out your box. But then you have to like plug in all these things here. Your stock is almost never like these shapes, right? So like it doesn't adjust for like the orientation of the cylinder and kind of things. So I'm gonna instead do from solid, and I'm gonna select the thing that I've made here to be the box. And so it's 60, 60, 19. That is the size of the wood here. And yeah, so that is the setup. So it knows all about the machine now, and I've got to tell it to drill out this crap here. So now you get to pick from all of the different fabrication things that it can do. And there's like too many of them. Like this one. So if I happen to have the drill bit where it's like, you know, a pancake kind of shape, I could tell it to make a thread, you know, like, or whatever. And then, you know, do I want you to draw circles around things versus I don't know, like boring is cutting down in a circular motion, engraving follows lines, you know, like all of these, like they're all just drilling holes, but there's lots of ways to do that when you think about it. You know, we brought up that whole idea of like, well, it's not flat, now what? Well, then you can click face, and so you can add an operation to your drilling that is, before you do anything, take your drill and go over the entire machine area and make it flat. And that's what a facing operation does. I'm not gonna do it because it takes too long, you know? There's yeah, these are 2D, and then you have 3D. So like, if this thing was one of those machines that goes on an angle, like, you know, you can spiral around and do all these ridiculous things. Like morph. Anyway, I'm not doing any of that. Yeah, so these are milling, where you're gonna like go down and like cut an area, and then there's drilling, which is just for like doing holes. If you're making a PCB and you have imported the if you're using Eagle or KiCad or one of these other PCB modeling programs, you drag in this thing and it comes with a set of drilling hole instruction things, and you can like put that in here and do the drill. Anyway, so this is, I figure, a 2D pocket or a 2D adaptive clearing. I'm not really sure. This is like, this is the automatic one, and this is the smart one, where or the one that like I select all the areas and stuff. I'm hoping that this will make a hole. And so then you gotta like fill out the form here. We've got a whole lot of stuff going on. Coolant. Well, this doesn't have any coolant. Some machines would do that if you know, like you get heat when you're scrubbing along, making a big steel machine do things. So tool. This whole process is just so like, if only I could just hit print. I have to now model the drill bit I'm going to use. Right? But like, it kind of makes sense because this drill bit could be big or small. And if I'm going down in the hole and getting it to move around, it's got to know how big it is. So sure, okay. But you know, it's a step. So all right, this is flat on the end, and it's a milling tool. There's so many different things. I'm making a new one. I'm going to put into my library, but I'm going to copy one of the existing ones that already exists. Turn on. This is like a roughly 2 millimeter, and no, it's 1.3. So it's got a flat end. Cool. And look, we were talking about this earlier. The speeds and speeds, what they call it. They make all these charts. These are built in. If you buy your drill bits from certain manufacturers that cost ridiculous amounts of money, then they'll have built into it, this thing will spin at a certain speed before it explodes. And you know, like it'll tell you what to do when this thing is cutting into certain materials, because before they sold you this, they drilled it through all of these and said, yeah, you know, if you go faster than that, that's when it breaks. So anyway, yeah. I'm gonna just start with this. Whoop, dang. And I'm gonna customize it. So I've is it in my library now? No. Tools, 3 millimeter flat. Right click it, copy. It's kind of a funny thing. Then you go to your library and paste. And what you'll end up with really quickly is all of the drill bits you have are in here. And then you find out well, I'd already did all the stuff for this one, and I'm not gonna use the other size. And then you break off that size, and then you go and model the next size. Anyway. Yeah, so check this out, I got to, oh, come on. Here, edit. I've got to tell it all of the different dimensions of this guy. They're actually on this big sheet, which is handy. So you can just program them in on the sheet and get off this gigantic poster. And there's, I don't know, there's a lot of details in here. And it's also not complete. So like, I always just measure it. Because like this, the actual measurement of a thing is usually the actual measurement of a thing, right? Piece of paper could be wrong. So this thing says that the overall length is 38 millimeters. It's 37. But whatever. So here. It doesn't have a special hold. This big blue thing is the holder. You don't need to model that out because it's not. I'm not making something where this is going down inside it and it would actually matter. So I'm just going to take the generic one. And so I'm using millimeters here. Flutes on a drill bit, and you've got the spirals going around. Those are called flutes. And so you got to look at it, and you look on the end of it, you can see that it has like 6 flutes.
Oh, there you go. There you go.
Okay, cool. Well, anyway, it is. I think the black would be carbide. Oh yeah. No, it's coated on the tip, so it's like titanium coated carbide or something. The diameter is the outside of it. These are all 3 millimeters usually. 3.1, but whatever. The overall length, yeah, I said was 37. It doesn't really matter like that much, the length below the holder. This is like how much am I going to have it sticking out of the holder that I'm putting it in. And so all of these tips are dipped, and I can see that it turns from black to gold. And so I usually just use that to line it up, or I mark them with a Sharpie. Be 18 millimeters. The shoulder length is when it's tapering down before it gets to the cutting bit, is like 6. The flute length, I don't know. About 9.
Like the.
Yeah, it's telling you exactly what's going on. Oh, the shoulder length is combined. So the shoulder is actually 15. Length below the holder, overall length, shaft diameter. Cool. This thing here is this thing here now, more or less. Cool. Oh, the shaft diameter is 3, but the bit is not. Right. This is the thing. This is actually drawing this, and I noticed that this is smaller on the bottom than it is on the top, and on this thing here, I didn't look like that yet. So, I think it's about 1.4. So 1.4. That thing is 3. Yeah. So it's like fat on the top, and then it tapers down, and then you get the tip.
It'll strain if you lift it up. No, it's okay, you're all right. I do the same. Yeah. It's like, there's one thing, it's not get around.
Ah!
So I know.
Ah! I'm gonna put this drill bit in here. And I'm gonna unplug the machine. So I don't scream like the thing.
No, the bathroom's so warm, I was like, I tried to.
Yeah. Also, the handle's messed up on that.
I took the lid off.
Yeah, I just noticed it
When I
in
put
this
it back,
one.
it's probably fall off.
Cool fast. Pass these around. I don't know if anybody's actually like seen them. So this here is the public column, and this goes down into it, and when it's screwed on, it like holds it tight. Cool. So when it's talking about the link below, it's like how that is held in there.
You have to measure that.
Yeah, well, I just said it was gonna be 18, so I'm executive decision, it's going. And so this is like silver and then gold, and I'm looking at that boundary and I measured that.
Yes.
So I'm just gonna put the boundary
See.
in there and say, there are these weird little flat pieces that you use to put that in there. One wrench holds the spindle from spinning, and the other one holds this nut on. So you can tighten the collet.
So these are specialty bits, or CNC.
You can go to Kent and grab a Dremel bit that is 3 millimeters and it'll work. I've got a bunch at home that I've done that.
Yeah.
There's nothing special about them besides like the you know, they gotta like work with the machine. So this thing spins at 10,000 RPM, which is pretty slow for like most tools. So everything works with it. It's also not very powerful. So a router bit might be like 1 inch wide and it's expecting to carve into wood. It's not a very powerful motor, you know, so maybe that wouldn't work, but you know, overall, and also like the whole collet comes off here. So you could actually, fit in theory, like other pieces in. I've never done that, but like good. So isn't this fun? Measuring drill bits. Okay, so no coolant. 1.4 millimeter flat end mill. And then we've got to figure out how fast do we want this thing to go. We're cutting into wood. Let's go. 5,000 is like halfway between it, like, you know, on and off. There's all these like things of like it speeds up and then it touches the material, and ramp up is like getting it up to speed before it interacts with the material. The cutting feed rate is set right now to 1,000 millimeters a minute, which is like really fast. This thing caps out at 650. So for wood, I don't know. I'm just gonna set it 300. Let's see what happens. I don't know. Feed per tooth. So this is the calculation it's doing. It knows it has 6 flutes. So as it's moving along at a certain speed rate, like speed rate, I'm saying certain spin. So if I move it a bit forward and it's spinning, how many cuts is it going to make in the amount of time that it's moving? So like feed per tooth, like you're doing these like little calculations so that you're like, you know, if you had a microscope and we're watching it in slow motion somehow, it's going to do like a cut and then a cut and move forward as it's cutting, rather than cutting a dozen times and then as it's moving. If it moves too slow and it's making too many cuts, it's going to just scrub and start to get hot, and then it'll burn your wood. If you go too slow, it's not going to fully make the cut before it goes forward, and then it's going to just shear off the drill bit and crack it. So okay, whatever. And then now we need to select this is the hard part. Select the geometry you want this thing to figure out and make cuts with. So I'm going to select this here. I'm going to hit shift and carefully, this is like operation. Yeah.
Yeah.
Skill. But yeah, but that's the thing, if I select the sides, it does weird stuff, so I've gotta like select the right, yeah. Yeah, we're playing Operation
Was
here.
that the right one?
I don't know.
Do it right?
I don't know.
I don't know. I feel like it's like Dungeons and Dragons. I was like, I'm gonna go
Fireball.
in there. See what happens.
Oh, no.
Operation.
I'm going to. Because I closed the window with my hotkey. My bad. Isn't this fun? And it all like resets, and I gotta like, I don't have to make the tool again though. I can just be like, hey, I did that one. So that's the thing. You generate this library, and then you know what's going on. These are supposed to get picked up from the config I did earlier, where I set the feed rate. It doesn't. I don't know why it. Okay, geometry. Yeah, this is kind of cracked.
There is an undo button.
There is undo. I hit the wrong button and
Okay.
went back too far. Like, so if I selected this and I want to unselect it, I just click it again and it'll unselect it. You can also go through here and remove or add pockets and also do weird stuff. These are called face contours and chaining. So I can like tell it to do these in a certain order and stuff. And I don't know. If you can think of a way that the machine could do a thing, for the most part, it does that. What it doesn't do is like make this process of using the software nice. Like the software does everything, but in the most painful way. So yeah, and then okay, stock contours. You can hover and you can get a full explanation of what that means. But it's related to the stock, and I selected this piece of wood as being the stock, and so it's considering the boundaries of this thing so that it's not drawing drill paths out in space, which I don't want it to do. So don't do that. And so I can select. Oh, actually, no. No, because it's a body, I shouldn't need to do that. This is some of the kind of messing around you need to kind of do depending on how your modeling is going. If I zoom out a bit and angle it, this is telling me about the heights. When I'm programming this, I want it to not run into the wood while it's moving around. So it moves up a certain amount. Well, how high do I want it to do that? And then it goes over and back down. And so the yellow is the orange here is clearance. So this is like getting fully clear of everything and moving around. The reason that's there is because my clamps stick up a bunch. They are really high. They're like 23 millimeters, right? And so this is saying, well, 10, is that clear enough? Because I know that I'm not, like once I get down here, I'm not going to go outside of the wood. I'm not going to hit the clamps. This is why these limit switches and emergency switches and things are important, because I'm making a decision here now that I'm going to not go high enough to get over these clamps because I'm not going over here. But if something goes wrong and it starts doing something weird, it might just plow right into the clamp and then break the clamp and the drill bit and the whole machine. But so like right now, all this is doing is it's like it goes up 15 millimeters for no reason, and it's just slow, and I don't need to do that. So I can knock that down to 5, and that will speed up the time that it moves around. The feed height, these are related to like this. It kind of gets ready and then it goes down. The top height is the stock, so it's the flat of the wood. The bottom height. So in this thing here, I've selected a contour and I've selected the bottom here of the area, and so the bottom height is going to be where the drill ends up. If I was doing an engraving and I selected the lines live on the top, and so I set my bottom to be how far down into the, say, brass plate that I want to go. So there's that. Passes. So this is not a very robust machine. I could tell it to try to drill down an inch and then go sideways. Well, I mean, first of all, it's not even an inch thick, right? So how much material do I want to remove each time it goes around? Because like it's going to kind of cut this really thin, and then it's going to go around and cut it again and again and again, spiraling down until it hits the bottom of it. So I want my passes to be 0.1 of a millimeter. So this is like 10. I want it to do finishing passes, which is to smooth it out at the very end. Step over is, it's like how, remember you're mowing a lawn and like maybe the pieces overlap, like it's like that.
Did you program in how deep you wanted to go?
Yeah, that was the bottom part. And so that's accomplished by selecting the bottom part here. But then how the step downs per pass are a separate configuration. It actually figures out how many steps to do when I say that so I'm setting the amount it goes down each time. I can also set it so that it's like do 7. But it's I don't know.
So you wouldn't put the bottom, as say I want it to be 10 millimeters deep.
Yeah.
Would the bottom be 10?
Yeah, the bottom, you set the bottom to 10, and then right here when I'm setting these configurations, it's like how much it moves down until it gets to the 10, you know, and so it's going to determine that it's doing a certain number of cuts before it gets down. I think, man, there's so many settings here. I may not know. This is the morph spiral machining setting. I don't even know what that's about. You know, radial stock to leave. I usually turn this off. This is like, for whatever reason, it's like if you want to not cut all the way out, and you want to finish it a different way because you expect that you're going to sand it, it'll like leave a gap and stuff like that. Yeah, this is for programming in things that I don't care about. One thing that is fast is to set both ways so that it can cut in both, like it can go left and then right and left and right. Otherwise it goes left, brings it up, goes back, and then it goes left, left. Now that sounds kind of ridiculous, but like if anybody's done painting, you know, like if I do a brush stroke, when I go down into it and then I bring it back up, the thing that's left on the paper is thick on one end and thin on the other. The drill is kind of the same way. So if I want it to be consistent, like if I'm machining metal or something and it's doing the surface of it, I can decide that I want it to look different ways, right? And so I can have it like all cut the same direction, and then the top of it will kind of have all these nice smooth lines on it. If it goes back and forth, especially depending on your drill bit. So if I cut one way, the drill bit is sort of like cutting into it. And then if I cut back the other way, it's cutting against it. Like, you know, if I'm cutting a spiral, it matters which way my drill bit spins, you know? And so if I tell it to cut both ways on a spiral, it's going to change the surface of it and leave gouges, but also it'll do it faster. So I don't know, there's all these like ridiculous things that you have to kind of like decide about. I don't care about any of them. Besides both ways is fast, please fast. Linking, so this setting is mainly, the main thing that matters is the selecting the place where it is going to start cutting, and I want it to be somewhere around here. The exit position can be anywhere. Pre-drill, sometimes you get it, I don't know, like if you want really crisp corners on, if I'm doing a square, I don't want it to treat the square as a weird circle and start doing spirals. I might want it to pre-drill the 4 corners so that they're nice and sharp, and then cut down in between the material. If I'm really fancy, you can get the machine to cut with different tools. So it'll use a drill to do the drill, and then it'll use a mill to go sideways, and then it'll use a facing bit to do the flat part and the finishing, whatever. It's a whole thing. Like there's a lot to know. Machinists do like a lot of training to get into, you know, professional versions of this. Okay, so this is what it figured to do. It's going to spiral on down, and then it's going to gouge all this out. And what is interesting is that it wasn't able to do these letters. Cool. We'll just do an 8, whatever. Yeah. Oh, and then also I can like simulate. Simulate's fun. Wait, exit simulation. I'm gonna simulate with the machine. And so like this is the size of this thing here. And I can like and my tool and all the stuff that I've put in it are there. And where is it? Oh, I didn't configure the post processor, so it's not actually doing it. What it'll do is it can simulate using the drill paths, and it can simulate using the code that it's output, and then runs a virtual version of the machine's Gerbil in order. I don't know. This is like different ways I can figure out how to. Yeah, I know. Gerbil. GRBL. It's the software that this thing runs inside. I don't know.
Do you get an estimate how long it is?
It does do that, and that's important because it can totally take a very long time. And then this is what it's going to do. This is what it's going to look like.
Oh, cool.
Look at it go. Look at it go. And so what I'm looking at here is like, why the hell is it doing this little spiral thing? And so I can go back and try to figure out why. This also, I don't know, somewhere or another. The screen's like kind of like not big. It'll tell me like where. These are the lead-in.
That where it comes down.
Yeah. Info. 5 minutes. Okay.
Oh,
Let's try it. Okay, so now I need to. I got like. I've done enough goofing around. I want this to become code. Please become code. So then I create a program with that. Oh wait, I'm in the simulation. I'm trapped. All right. I want to set up a new program. There's actually 2 ways to export, because there's like 40 ways to do everything in this machine, in this software. So I'm going to set it up so that it knows the program, and this allows me to name it and give it steps. The other option is just like say export, and it dumps a bunch of code into a folder, and you have to like sort through it later. Anyway, so I'm gonna do this. Post processing. Autodesk. So this is the thing that converts the here it is. It converts the toolpath to be the G code for this machine. I'm actually going to download the good stuff because it's free. It's here. Maybe. I don't know. Let's see. I want to download that. Local. I don't know. I don't remember how to import it. The only thing. Maybe. That was maybe. I don't know. Sure. I don't know. Maybe.
it's okay.
Yeah. Okay. This is working. See, remember all those codes and they all mean stuff. So safer tracks. The machine can be programmed to know that it is a certain height, and then that is a safe height, and so you can program in to use the pre-programmed thing. And I don't want words in it. I don't want it to tell me about the machine. I don't want it to add a bunch of crap to the top of my file because it's not instructions. I just want the instructions. I wanted to avoid the helical, whatever. It's fine. I don't want the tools. And name, I'm gonna call this EE logo. And post is to post process and write it to a file. So that lives somewhere now. Oh dang, I didn't actually put a text editor on here. I wonder if there's one here. We'll find out. So this wrote it to somewhere. And it's in the configuration. I'm used to doing this on my home machine, so I'm like, I don't know where anything went or what happened.
The thing you just saved,
Yeah, I saved it like to the default location. I don't know, like,
I think it's the folder. Fusion free, yes.
NC programs in here. Cool. All right. Well, that's a file, and then we're gonna go back to this thing, and we're gonna open that. Documents, Fusion programs, logo. Hey, look at this. This is the logo, except for all the pieces that were too small for it to like figure out. And now I can also use the height map if I want to do that. So I can tell it to like see this little grid that it's making. Auto. It like I said that I had a piece of wood that was a certain size, and so now it's able to like go in and actually like, I don't know if you can see them. They're like there's a dot here and a dot here and a dot here, and it'll figure out all those heights and like adjust and do all this like whatever. I'm not doing that. No, don't use icon. Okay, cool. So I'm just gonna get it to try to draw that. Now notice it thinks the drill bit is over here, and it's gonna start drawing over here, and also this is in some random place. So we don't like those things. We gotta like start it in a sensible spot. So it doesn't have any of the safety switches. They do two things. They're not just there for keeping it from ripping itself apart when it slabs into a wall. They're also there for starting it up. So when you turn it on, it'll bump into the wall and bump into the other wall, and it knows it's in the corner. So anyway, I didn't set that up. That's called a homing routine. And there's even like a button here that'll pre-do those things. These commands are comments also. Sometimes actually every time for me, I'll go in and I'll like delete these from the file before I send it here. I don't know if you even have like text editors installed and stuff on this, so I'm gonna see what happens if I leave them in there. And then I'm gonna set this thing up. So we've already got the drill bit in there. This is on and alive, and so I need to position it in the center of the wood because I told it that it's gonna start here, right? And so I've got to put this here. And so usually what I'll do is I'll get something thin, like a little piece of paper or some kind of scrap or something. And doing a little routine. I want it to be close, but like not touching it, because if I just let it touch it, it's going to just plow itself into the pine. So I'm going to lay that there and say I want it to go down until this is pinched. And so I set it to jog, and I slide the thing over till it's centered on that axis. And then do the same to the next one. So I'm centering it in the piece of wood. You'll notice in like this plate here that like I marked the center, and so I'm going to get it to go right down there, and then sort of drill out stuff. And now this is the tricky part. This is where I've got this piece. So it's carefully going down, like certain precision, and then driving itself into the piece of wood. So I'm going to set it to 0.1, and this is the process. I wiggle the piece of paper until it doesn't wiggle anymore. And I just keep clicking this because I can barely see it moving, but at some point, my paper stops wiggling because it's being pinned, and then I know it's on the surface of the thing. That's it there pretty much. Yeah, I can't move it. So back it off one, take a piece of paper out, and I can see that it's like just barely on the surface of it. So that's how I set up the thing. And now the little animation of a drill bit is like gone. I don't even know where that is. So I'm going to say this location is now the starting location for my drawing. and then pray that it works, and then you hit send, and you send it. What?
Oh.
Don't do that, because it's not gonna work. It's just gonna like, you're gonna get a video of the machine ripping itself apart or something. Yeah. Okay.
Job done.
Reset. Okay, so this is the thing. Something about this in the code that it exports is not correct. This happens frequently in that your machine is running a very particular version of the code, and then Autodesk is exporting a very particular version of the code. And so I think I know what this one is. There's like a particular instruction I got to tell it to go down 5 millimeters, and nobody knows why. You can catch that sometimes if you just look at the simulation. You'll see it do weird things. Like, I don't know, this like helical drill down is funny. I don't really want it to do that.
I have to take off, Jordan. I gotta.
Okay.
Be at home. But this one's really.
Yeah. I'll mail you a stamp later.
There's a whole world of this.
I don't know anything about it.
I'll see you later.
See you later.
I hope it works.
Actually, was that just spinning on the?
Spinning, but
Oh, damn,
it
maybe-
didn't make contact.
But like, did it go sideways or was it just spinning?
I think it moved.
Because it actually might have just been the lead in. Maybe it was right, and I just jumped the gun on deleting it. Actually, I'm gonna figure out how to make it not do that lead in, because it doesn't need to. Where?
Lead in is there, the helical.
Yeah. Okay, this is the 2D pocket operation. Edit. There's so many things. Linking? I feel like it's in linking.
Lead in. That did on the.
Lead in, entry. No, I don't know. Lead out. I don't know. No. Ramp, helix. It didn't. I don't know. No. Edit. Stay down. Safe distance. 1 millimeter. Keep tool down. Tries to minimize. Like when it goes down, it comes back up. It tries to minimize how high it moves it when it's like cutting down, say, between all these letters. Maybe that. Okay, cool. Setting it to plunge made it not just spin randomly for no reason. And so my program's out of date. It turned all yellow. So I need to post-process it, overwrite the thing. And then usually I'll go find it. I'll open it with, I don't know, what do you got? Notepad?
Yeah.
And I delete these comments because they don't do anything, and some of them actually cause strange problems. But I don't see the ones that I'm most concerned about. So this is setting the starting location. This is setting the spindle rate to 5,000 using tool in3. Like these are just like drill locations once it gets into it. There's a lot there. Fusion. Yeah. So, the fun thing about this, and I don't know why, I don't know if they fixed it in this version, but if I hit delete lines, well, okay, it says delete lines and I hit yes. Inexplicably, all other versions of Candle, that pop-up in particular was in German and it could never be in English. Yeah, it's just like, nine? I loved it. Yeah. Save, no, I didn't do anything. Height map to save, no, okay, cool. And
Okay,
wait, I gotta get it back down to the starting position again. Yeah, you can just eyeball it too, but like it'll mark the surface of the stuff. So if you're doing printmaking, you may not want that because this is not necessarily a cut location. It's just a spot. And anyway, try again.
It's doing a thing.
Yeah, that's actually not too bad. Cutting grass is. I did it in the middle of the night. It was like, what am I doing?
Why are you doing it real night?
Sometimes you get started at something, you just want to finish it, right? You want to see what's going on there. This is why I left it.
I think we'll be live, right? Right there.
Yeah. It tells you what's been cut and what hasn't.
Look at this little back.
See how many passes are left.
Did that come?
No.
No.
This is a tiny vacuum I found specifically for this.
That's so great. Put that on a list. Who knows what you're using? Plaster when we're sanding and stuff. Yeah.
So that's it. Now you've done a thing and you can do stuff with it. Any questions?
Compared to the 3D printing, it's so fast.
It's fast.
Yeah.
But this part is not fast.
So, well, it depends on what you're doing. If you're really familiar with this and not talking while you're doing it, you just get into it.
Yeah.
It gets quick. And also, this cutting, it depends on what you're like. If you are trying to be careful and not crack the bit off while drilling hard metal, it's slow. If you're, I got this like foam here. This like and it's just like we all that. But if anybody wants to make a stamp or something, we got lots of wood and materials. We can try to make some stamps.
Wow. Pretty cool. So like the biggest part is getting it ready.
Software to communicate.
Yeah.
Yeah, once you, like you say, once you set it up on a couple, you know what you're there. Was it done?
Oh, I'm not sure. Where's it going?
I don't know.
Where's it going? Oh.
Okay, so that is the kind of thing that you have a button for.
Yeah.
Because it does stuff like that. What that is the foaming routine that has been pre-programmed into the device by the manufacturer. So, yeah, and it's a bit rough, right? Which was great when I was trying to get burrs in order to hold ink and make a print. But in this case, this is not good. And so that's what the facing operation is for. It'll go and fix that after. These kinds of things, I just get a piece of sandpaper and I just sand it down and that'll work, you know? And
Yeah, it needs to be sanded.
yeah,
Just a little.
Oh, gosh.
So if you want to
So-
prevent that tear out, like, you know, there's things you can do with this, because it was cutting sideways to it, you could get it to cut so that it's like, it knows about the grain of the wood and like all these different things.
But this is the little bit you would wanna use for stuff like this and wood, not the,
Well,
you use the
oh, yeah,
pointy
some
thing,
different
yeah.
bits. Okay, so, these are milling bits. And they're weird, they're bidirectional, so they can spin in either direction and still work. Yeah, these are milling bits, they're made for going down, and then their rough surface will like cut channels. Then this here is another kind of milling bit, but it's like, this has got a lot of teeth, and this has less. It's more of like a drill. This one is for they're for different materials. This one here will do metal, and this one here is probably actually better for wood. I didn't realize these were here. I guess we want to paste that. These are engraving bits. They're like a triangular tip,
right,
and
you wouldn't want that on that.
you have to be careful when you pull these out, because
Sure.
this is a piece of like wax, and I've stabbed them in my fingers too many times. So this is an engraving thing, and it's mainly for like roughing up the material. It spins, but it kind of doesn't do a lot, you know. But it leaves a really nice finish. Like if you just do like a square with this, it'll kind of look like frosted, you know. That's why I used it on the plate there, because it's like the frosting. It's making all this like burr, so that's good for holding ink, you know. But yeah, there's all kinds of different drill bits, and
I
this is a fraction of what you can get.
I wouldn't use that with wood.
I have, it actually does a fine
Yeah?
job with
Oh,
wood.
okay.
It might not have had the same tear out on the edge.
That's what I'm wondering.
Because the flat bit will carve like on an angle down, but what the flat bit cannot do is the flat surface when it goes inside. If I want a sharp edge, this is the trade-off, and like, you know, there's different materials. The soft wood does this, but if I use, that's why I got poplar here. This is probably less likely to do that, you know, so
Yeah.
I don't know. I'm thinking I'm gonna try it again, cut a little piece off. I don't know if we gotta go or whatever.
Take your time. Well,
Anyway.
it's 9:19, it's up to everybody else.
Yeah, so
I'm,
that's
I'm
all I
probably
had.
gonna have you come back later, quite honestly, because
Mhm.
I'll try to do it myself. Maybe once, maybe not tomorrow, probably next week. And
Give me
Yeah.
a ring, I'll come down and like.
yeah, this is like, wow, look at that.
This is right down my alley. I learned AutoCAD in like 2007.
Oh, yeah.
Oh, go on, okay, you know what's
Yeah.
going on.
But like, yeah, I know. It's wild. I recently like have poking around on it. It's like, oh, all of these things are now automated. Imagine
All
12
that
years of
time
technology later.
learning.
But I like the fact that it's so.
I made these years ago. I've never used
You
it.
can adjust
But-
everything.
yeah.
in.
Like contact
Down to the
info.
detail, it's
Yeah.
nice.
Yeah.
Oh, let me get one of those.
Well, if something doesn't work, you know, and
You save this. But yeah,
But,
no,
yeah,
like,
give me a shout, you know, if you're out.
it is particular, yeah.
I've done a lot of wood and it hasn't been that bad. This was like the
Oops.
worst piece of scrap that I jammed in here, because I was figuring that the first one you do is always just garbage. And so this is like,
Yeah.
you know,
yeah.
this is to set it up, but like, so now, when I set it up, it was right in the center of this thing here, and like, so looking at the logo, so I need to do this again, right? I got a drill bit that's a certain size, I need to fit it in here, so I need to make the logo bigger. And also looking at the logo, so it goes over about this far, so I think it was actually fine for like the alignment, if this cut down, you know, and then down that way.
Yeah. Oh, yeah.
It would have looked like the logo.
Yeah.
So like the origin was good. Like the rest of it was good. It's just too small. And I can also get a feeling for like, I was trying to avoid the clamping, but if I did the thing with the tape, there's a tape here. And then you can tape it right down to the bed or to the wood. And then you don't have to worry about the clamps. So I could have scaled this right up to the edge.
so it doesn't put too much pressure against the wood.
That's fine. Yeah.
Yeah, it's not gonna move out the tape.
Yeah, the tape, like, try to get this plate off, it's like on there.
Yeah, okay.
Carpenter's tape?
Yeah, it's like special order, I got a bunch of rolls of it, so like all the things that I brought are here for this thing, on its own. So like the thing is now this needs to get bigger. So like I'll do another one where I try to scale it right out to the edge of this. And hopefully now that at that size, it should start to get the letters, and like so, you turn around a bunch of little scraps of wood
Yeah.
until you get to a point where hopefully it looks like a proper block, and then you've got a stamp and you can go and use it, right?
So if you wanted to keep it that size, but do the fine details, is it just a matter of doing a different bit?
You have to adjust something, right?
Yeah.
It's just like physically, that is the
should do it.
smallest. Well, you got to measure it out. So we can open this out.
Can you the letter?
So this is 37 wide. I don't know if I can do a grid. Can you do a grid?
Well, I gotta run.
Okay.
So thanks very much.
Yeah.
Yeah, you carry on.
This will be uploaded and.
Yeah. So, yeah, no, it's great. I mean,
Information
I
overload
got
or?
some, no, I got some, got some planning to do. I'm gonna have to get one or
Yeah.
play with this one.
Well, there's one here.
Yes,
I got
that's
one.
good.
There's lots around.
All right, so thanks very much.
See you.
Hey, thank you.
So like I'm setting up a grid here. I assume that I can set these to millimeters. Spacing.
Yeah, the scale's at the top and it's the 48 by
Whatever. 48.
like the grid here.
Oh, right, yeah, okay. So like let's make this like an even 0.1. This is 0.1. Okay, and so I'm getting a feel for the thing here that like this is 1 point a little bit. This is 1.4. So I need to scale these letters till this fits down inside it, or it's not going to do it. Like the problem is that my drill bit is just slightly wider than this line. There's no way to do it. So if I do like I need to actually like adjust the drawing if I don't scale it up. So I can I don't remember Inkscape. There's a way to just like make it all fatter.
Yeah, I know, I forget what it's called. It's offset. Yeah.
This seems like a thing. I don't know. Control A. Offset, please. What? I don't know. Anyway.
Yeah, I know what you're saying. Yeah.
Yeah.
So yeah, that's the kind of the
As
deal.
long as it goes. Yeah, and so like as we selected this piece, but you can select it to go all the way around the whole thing, right? In one go.
What do you mean?
Do you know what I mean? Like, so we only carved out this piece, but to get the rest of that,
Well, yeah, it's just that it wasn't thick enough.
right?
So if
Right.
it could have fit down there, then it would have drawn. it.
Yes,
Just like the letters, like it
Yeah.
applies the same.
Yeah. You can see looking at this that this is like one and a little bit.
Yes,
It just didn't fit. So
it's cute.
and that's why you have to like kind of this looks horrible.
Yeah.
You're like advertising. Let's go. No, so if you want to avoid that tear out, you can use different kinds of bits that have different tapers to them.
Okay.
You can do the finishing cut is able to take that along the side a bit cleaner. You can change the directions. There's all these little. The reason it's so complicated in Fusion is because the actual material properties are that
So
complicated, So
Yeah. No, I mean that.
Hmm.
Yeah, I get it. I'd rather be able to tweak everything than having a machine tell me what I'm supposed to do.
well, yeah,
Just because, like, I don't know, like, I feel that, like, if you wanted a very specific look or texture, or
Yeah,
shape, like, you're able to kind of hone that in specifically for like your material and purpose.
it's not to say that the software couldn't still be better. And yeah, the like really primo versions of all this handle these kind of problems,
Yeah.
But anyway,
It is what it is.
It's pretty cool.
It's
There's
very cool.
there's tinkering to be done,
Yeah.
and I guess we need one of these.
no, you got that one.
What do you mean?
I have 5 or 10 of them.
Oh my goodness, okay.
Gotta figure out how to attach it though.
Yeah.
I brought the wrong size.
Where does he stop, man? It's so.
Yeah,
cute.
actually, I think that there is excellent Y limit. I don't see an emergency stop on this.
No, and even if you did, it's so small, you can't be.
Some of them
finding that.
do, you know. No, like some of them, like wire it
button.
on, it'll socket onto that instead of putting it on the power.
Mm. Oh.
You see these say X limit right here on the bottom?
Mm-hmm.
So that is the switch that'll go on the thing to
Oh, the
keep it
things.
from ramming into the wall.
Oh, go on, okay. Oh, yeah, oh, okay. Why would
So
you-
some of them have an emergency stop pin,
Mhm.
and you can. I mean, it might be whatever the hell 1A is. Or no, 1A is gonna be the probe for probing. I think.
Could you just cut the power?
Yeah, well, that's what this is. So this one would have you get the cable here,
Oh, you're just.
and yeah, you just you know right, but it's just that this doesn't plug in because the
Gotcha.
inside is too small.
Cool. Okay, fine.
If I had a drill of some kind, I could make it bigger.
If only you had a drill of some kind.
It's that. Oh,
So
my
as it
God.
stands right now, the machine doesn't have an emergency stop or does?
So you can do this.
I guess, sure. But this is better because it's, you know,
Yeah.
The big
Like it-
obvious button.
it's huge.
Yeah.
Safety.
I love the big red button.
I know, me too. There. Oh, my God. Jordan. I'm gonna be bothering you several times, I think, until, yeah, this information is just like.
There's a lot, yeah, I know, I feel like I'm Horace just ranting and like nobody's asking me questions, but there's definitely a million, it's just like,
Questions, people,
You know.
yes, we have questions, but yes,
you know, just it's that kind of thing.
we're gonna get stickers.
Yeah, so I got a hell of a lot easier than this, I got a Cricut home, where you just like, you know,
Yeah.
drag and drop, like, here's my Illustrator thing. Make it,
Yeah, there's so-
Shoot
Maybe we
sticker
should get
comes
one
out
of
the end.
those.
They're great.
I know,
I can teach you those because I use it for my stuff.
I used it for work years ago,
Going
but
to
I
all
don't know
business
about
cards
putting it
and
in.
packaging and paint tags and
Yeah.
everything on
Oh, they're
board.
great.
I know they're so good to have.
Yeah. You can even do the whole pen. That's something else that
Yeah,
came up.
that's what I have.
So-
Set up, it holds a pen, it doesn't grade in.
So this thing here.
Mine cut out the balsa wood.
Yeah,
So
yeah, yeah.
like, I'll do all
The big
my
ones.
powder
Yeah.
and I do all my stencils and stuff, like the piece I did for Fair and Square with the
Mm.
tile.
Yeah.
So I designed that all digitally and then I have a stencil vinyl that I did on the ceramics and then airbrushed over top.
Yeah, yeah.
So I was able to like take a picture of a piece and draw specifically for the exact size.
And stencil.
And then just have it all cut out.
Yeah.
So yeah, so like.
That's
this
not
is
even
what
get one of
this is
those.
Like,
It's the right tool for the thing that you're doing. So that it's got a drag knife on it. And so it goes down and cuts and it's got to physically drag it, but it's not that powerful, so it can do balsa wood, you know?
well.
You can put a drag knife on these. Yeah, oh yeah, I know, yeah.
Cause like the one I have, like the knife on it actually is motorized
Yeah.
as a circle as well, so it's always.
Yeah.
Yeah, it's very neat.
And then it can hold a pen.
It's got a,
Yeah.
there's a pen holder version, yeah.
They all come in.
Do that. Oh, my
But-
gosh.
Like, you can put a pen, you can put a knife, you can put other things in this, you can put a laser in there, whatever fits.
What
the
if I
mold.
made like a,
Yeah.
like a cake and then just put
People do
the
cakes.
icing and just,
Actually,
Oh,
there's
yeah.
also a Cricut cake.
Yeah.
oh my God, that's
Uh,
crazy.
There's also an attachment where one of the motors, you take this piece off and it spins something instead, so you could engrave a mug.
Oh, I see.
Or round things, you know, or you could like, I don't know, carve a sphere thing if you wanted to make, I don't know what you'd be making, you can make all kinds of things.
Oh my God.
You could put a brayer in it or something, you could like carve out different rollers, make stuff. Yeah, lots of stuff you can make with it if you get used to it, it's just a lot to get used to.
Well, yes. That's okay, it's okay, it's lots of time.
But I think it was great.
I'm gonna look at the
laser engraver to do
Yes, what happens?
designs like similar to ones with roller pins.
And next, what
I
I got
a laser
was
cutter. I've been
broken,
looking at
and it's
the,
one of the fancy things. I am never buying fancy.
This is
ones
local
ever
on
again.
Facebook
I'm
Marketplace.
getting a shitty white
That,
box.
that's not what I
It
want, I want the
just-
big one, I want,
Yeah, but I've seen the photos.
That.
There-
It's the computer.
Yeah, if you're like want a cricket that has firepower. Yeah.
Oh, yeah.
They're like clappers. Yeah, because of burning the material, right? But like I want one like you get ones that are like this big and you can. There's like I've used them before to make I made a robot build and we made like all of the smaller pieces out of like acrylic and like I made the controller for it. So when you test it, like it was autonomous, but you needed it was RC.
Yeah.
So I made like the little case out of acrylic and I made like puzzle pieces out of like sheets of acrylic that like just went together and it was so nice and like they were you know even like you know the big laser cutters are great. You can make good
Yeah, laser
physical
cutter.
things, you know. Except for also then you die because of inhaling.
I would kill myself, so I. I have so much ventilation, I could like. Compete with the gales, like. Seriously, it's, wild, but.
Maybe I need to get a little cry cut.
Well, you can borrow mine if you want. To like give it a bash, see if it's like something that's.
Yeah, that's the thing about all of these. They just, you know.
Well, yeah.
If you're not gonna, like, a lot of people get them thinking that it's.
They're gonna
like,
use some.
I'm gonna start a business.
inspired,
Just
yeah.
wait.
But like, there's a learning curve to everything.
Yes.
Unless you're
Yeah.
willing to, you know, but as I explained to people, like, these machines were made for soccer moms to write live, laugh, love on. So like, you know, if you as an artist cannot like use it, then maybe you need to reevaluate it. Because like, not art, you write grants.
Yeah.
Sweater. and all that
Oh, yeah.
stuff.
I made t-shirts with it, like.
Dang, yours and-
Actually, you know, all the stickers, the same links? Yeah. I did those on my target.
Oh, sick.
Yeah, so I like printed, I have a photo printer, so printed them off, then like, they do like a die cut. Or laminated them, then they do a die cut.
See, like, and each next needs stickers, and we need like.
Yeah, and I actually priced it out, it was cheaper for me to buy the materials and do it myself.
Oh, really?
Yeah, because it turned out to be like 10 cents a sticker as opposed to like 25, because I wanted to do
Huh.
the holographic.
Oh, that's great though.
Yeah, so it's like equally.
No, because it covers the cost and you're like, it doesn't even matter now.
Yeah, so it's like, my labor is like the only expense, but when I'm in the studio, it's like, I just set it to print and cut, like, say 20 sheets. So all I have to do is like take it out of the printer, feed it through my laminator, and then stick it to the